This episode is sponsored by Linode. Linode is offering listeners of this podcast a $20 credit, which is good for 4 free months at their lowest plan. Their plans start at 1 gigabyte of RAM for $5 a month. You can get your servers in any of their 10 data centers, and their high memory plans start at 16 gigabytes. Get a server running in under a minute. They do hourly billing with a monthly cap on all plans and add-on services like backups, node balancers, Longview, etc. VMs for full control, running Docker containers, encrypted disks, VPNs, etc. You can run a private Git server. They provide native SSD storage, 200 gigabit network, and Intel E5 processors. They have 24/7 friendly support, even on holidays, and a 7-day money-back guaranteed. So go check them out at linode.com/JavaScript Jabber. Hey everybody, and welcome to another JavaScript Jabber. This week we are still at Microsoft Connect. I'm talking to Nishant Thacker. He works on the data team for Microsoft. Do you want to give just an explanation of what you do? And
Sure, Chuck. Yeah, I'm Nishant Thacker. I'm the technical product manager for all things big data at Microsoft. So, look after the Hadoop stack, all the Spark offerings, the newly announced Azure Databricks service, everything with regards to Azure Data Lake and Stream Analytics and Advanced Analytics as well. So, yeah, pretty interesting stuff there.
Totally. Now, this audience is mostly JavaScript developers. We have people in other areas as well, depending on what their expertise is. But I don't know. A lot of people are starting to get into big data, either because they're looking at having large data sets for machine learning, or they have some kind of reporting that they need to pull together, or things like that. So how do you at Microsoft think about big data? Like, how do you define it?
So yes, that's an interesting question. A lot of people think about big data as just big in volume, but big data is not just about data that's big in volume. It's also about the complexity of the data that's coming through. In essence, it could be about the velocity of the data, the speed at which you're ingesting it. It could also be about the variety of data, the types of data that you're catering towards. Of course, in addition to the kind of processing that you want to do on that data. Do you really want to go ahead and just write some aggregates, or is it much more sophisticated analysis of that data to design or devise patterns from it? So that's like, from our perspective, big data is defined by 1, the volume, 2nd, the velocity, 3rd, the variety, and 4th, even the veracity, and even the kind of processing needs that you have on that data. If that gets outside of the realm of the traditional systems, that's when we define it as big data.
Right. So one of the things that I have a handful of systems that I've always talked about building, right? One of them is kind of an analytic system for podcasts, right? And so initially it's just going to, collect data, and it's not going to be that large. But eventually, I'm going to want to process it and say, hey, look, we have a lot of iPhone listeners. Well, I'm going to want to process it and say, we got so many downloads of this episode on this day or over this time frame or things like that. And it seems like the traditional thought processes around large data sets with machine learning is overkill. I just need something that can process the data and give me the certain metrics that I want from it.
Certainly, yes. I mean, there are these metrics around. Let's say you just want some basic analysis around your listeners. Well, that's perfect. You put your podcasts out. You even go ahead and understand who your audience is, how they're tracking in. Are they mobile listeners? Are they web listeners? Are they tablet listeners? Are they listening it via an app? Are they listening it via a portal, etc.? That's pretty easy stuff. Now, just imagine if you could now go ahead and associate those numbers to specific patterns or specific topics or specific terms that are being discussed inside of your podcasts. Just imagine if you could go ahead and determine that your listeners want to listen about iOS topics much more, even during potentially discussions or podcasts which are kind of tangentially related to iOS, right? And that way is you get an analysis, a deeper insight into what your customer's behavior is. How much duration do they listen to? Are they looking for specific tones before they switch off? Are they looking at specific insights before they can really get engaged with your podcast? And that is the analysis that traditional systems cannot actually accomplish. That's where you need systems which go beyond it, which can read into audio files, potentially even look into trends of click streams, etc. And that's where you really get into the realm of complex data processing and big data, etc. You actually asked a very good question early on. Like your listeners are JavaScript listeners, and I actually wanted to mention that like JavaScript developers are actually a very large chunk of the open source analytics stack development as well, because irrespective of what is it that you're creating, you have a very rich set of capabilities in terms of what monitoring, what capabilities, what administration, and what kind of performance retrieval, etc. you can do. And JavaScript is one of those options that open source developers are very used to, and they leverage it to the fullest within the Apache org and the foundations there.
Yep, absolutely. So I'm kind of thinking, I mean, you talked about the capabilities that we have both with JavaScript, and I think the way that JavaScript developers think about some of these things, especially as it relates to communicating over the web and things like that, those are things that we're very comfortable with. So as far as like sending data to a large data system and some of the scripting around it, you also mentioned, JavaScript is a first-class citizen in a lot of those. So, but how do I get started with this? Like, how do I start to envision my big data? So I have this data set, or I'm sending this data set to a service in Azure or Microsoft, or maybe I set up my own Hadoop cluster, so whatever, right? So I start putting this information in. I mean, what do I do with it then, right? How does it get processed into a report or information that I can use on the other end?
Very good question. I think this warrants a little bit of discussion into the concept of a data lake. So, in the big data world, a data lake is a data store where you can just go dump all of your data in its raw form. The theory behind that is that users don't even know the questions to ask of this data today. You might have more questions of this data 2 years down the line that you can think of today.
I have to say that's actually something that I've been concerned about, right? Is, am I collecting the data points that I'm not using right now? I'd like to be able to go back as far as I can when I come up with, what about that?
Yeah, and that's exactly the point there. If you have that data lake created and you have that data lake maintained in a way that you can tap into as soon as you get that question from your business perspective, you can tap into the data in its raw form. Now, remember, the data being in its raw form is really important, because raw data has attributes that can be missed out if you go ahead and pre-process it before storing it into your data lake. Now, coming to your question as to how do I convert this raw data into insights or reports or graphs or charts? Well, that's a process that the compute clusters help you achieve. Now, when we say big data, we usually mean a lot of complexity. We also mean a lot of scale, which essentially means that you need specialized engines to be able to process that data.
Right. Just to illustrate that, I think most of our listeners are familiar with MySQL or PostgreSQL. Sure. And so you get a table that has millions or hundreds of millions of records in it, right? And you go look something up with or without an index sometimes, it's really slow. Yeah. And so, it's like you need an engine that's different from your traditional one, because I want the report now. I don't want it in 20 minutes when you finally grind through everything.
Exactly. And that's the point. Like, those engines are scale up engines. That means that you can associate more CPU and more memory into a single box and then keep ramping it up. But then there is a limit up to which you can reach. Beyond that limit, it's like, okay, can you go buy another machine and move some of these workloads off of this machine to that other machine?
Yeah. Go
Well,
get your friends to help me paint this fence.
absolutely, yeah. But then in the big data world, that is a problem from day one.
Right.
So the way that design works is not a scale up, it's a scale out.
Right. Absolutely.
In essence, you're literally going ahead and saying, okay, give me a set of cheap commodity machines, which are very low cost, but give me a number of them, potentially 100, if not 1,000 of them. And what I do is I can now go ahead and connect each of these machines to now use the cumulative power of all of these machines to go ahead and perform my job, right? Now, which means that job that took you 4 hours to process and get your report can now become a job that gets completed in a minute. And in essence, you're getting responses back in sometimes interactive response times with new engines like Spark, which do in memory processing, etc. Now, again, even within memory, it's a cumulative memory capacity of all of these machines that is getting leveraged. So, that is really important for people to understand that big data means scale out. And when you scale out, you get the cumulative power of all the individual machines that you're coming in from. Now, as we get along that process, that is just one part of it. The scale out is for the scale that you need, but then you need specialized engines to process specialized kinds of data. So you could be getting a video file, you could be getting an audio file, you could be getting potentially JSON files or XML files or CSVs or even plain text files. Like, how do you go decipher all of that? So, for that, these big data engines have specialized languages and tools that leverage the knowledge of Java internally or Python, etc. And you can now go ahead and leverage those tools to decipher insights from it. For example, the podcast, I could go ahead and write a query on this particular podcast's audio file to determine how many times Nishant mentioned big data, and I would get a response coming out of that. Now, just imagine if I could join that query with the number of users who listen to this podcast. I could potentially go ahead and deduce what percentage or what probability it is that your listeners would love to hear more about big data.
Yeah.
Right?
Right. Yeah, that's interesting. And then, so it seems like I think the analogy that I usually hear is map reduce, right? And so you're talking about mapping out all the information that you need. So how do you bring it all back in so that you have a cohesive report at the end of the day?
Sure, yeah. So MapReduce is like a very primitive way. Well, like when big data first came to the fore, that was the engine. MapReduce was the engine that we would leverage, and Hadoop works majorly on it, right? Now, in essence, what happened is there was a progression that happened in that area, as with JavaScript, as with any other language, as with any other engine. And today we've kind of come a lot more in terms of an evolution from that engine. Now, to explain, conceptually it's still the same. It's still that, okay, when you get a large amount of data, instead of storing it in one single environment or one single place, what you do is you split it into much smaller chunks and you spread it across those multitude of machines that you have, right? And then when you want to fire up a query, what you do is you fire up that query, but that query gets translated into a split query across all of these machines working on that small little chunk of data in those machines. So just imagine now, instead of querying across, let's say, 100 terabytes of data on one machine, I'm querying across 1 gigabyte of data on every machine with potentially much smaller CPU, but still good enough for me to be able to query that 1 gigabyte of data in a fraction of time that would take me otherwise. And if all of this is happening in parallel, that means eventually spend just a fraction of a time across the entire query. Now, once that query is calculated, there is a phase called shuffle, which essentially means that now I'm able to aggregate these results from these individual chunks and give an aggregated result across this query back to the user. All right, so imagine a query that would take, let's say, 100 seconds in a single system now takes just 1 second across this 1 gigabyte of data in smaller systems, and now it takes another 1 second for the shuffle phase, or a fraction of 1 second for that shuffle phase, which means your total query time is now reduced from 100 seconds to 1.2 seconds. All right, and that's the entire phase of map reduce that's happening over here, which is allowing us to get that query response in such short a span of times.
Right. Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says "Pay me now." And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
And so when you write this query, you're telling it what information you need and how to format it so that you can use it? I mean, what's the structure of this query, right? Is it pull all this stuff out and then eventually give me this? Or do you have to give it a step-by-step?
All right, that's a very interesting question. So, in essence, as a developer, I don't have to do anything at all. It is the engine that is taking care of spreading or distributing that query across the multitudes.
Right.
So if you're using Hadoop, it's the Hadoop engine. If you're using Spark, it's the Spark engine. If you're using Azure Data Lake, it's the Azure Data Lake engine. If you're using Azure Databricks, it's the Azure Databricks engine. If you're using Azure HD Insight, it's the Azure HD Insight engine, which is taking care of that. You, in essence, are just trying to say, okay, select count of users from my podcast table who have been listening for the last entire week.
Okay, gotcha.
And that's the query that you write. But internally, that query gets translated into a distributed program across all of these nodes, which the user doesn't need to worry about because it's the sophistication of the engine that is abstracting it so that you can keep it easy, keep it to your business, make it happen over there. But then if you're a really good developer, and in turn Java developers are the ones who use this the most, you can actually even go ahead and program at the assembly language level to potentially optimize those queries even better. You could even go ahead and say, okay, instead of breaking it down into chunks of X megabyte blocks or X gigabyte blocks, go ahead and break it into chunks of X into 2 blocks, because I understand my query. It's not going to query across all of these data sets, and it's just going to query across a small filtered set of it, and I can leverage my capacity better for that filtered set. So
That's really interesting. So then how much of a difference does it make how I store the raw data or how I ask for the data?
Again, a very good question. Again, that's something that's completely abstracted from the developer or the data engineer, as we call like the developers who work in our world,
Right. But I
right?
can see, like, if I'm running a Node.js application and I'm sending request information to the data lake, right? If I structure it one way versus another way, I may be able to optimize, the query that I eventually send to the system that gets, disseminated down and back up, versus another way. Or does that just really not matter because the engine abstracts the data structure away from you?
Well, I think it's important for us to understand one thing. First, you would not have a Node.js application talking to a big data cluster directly. Never.
Okay.
A big data cluster is for analytics needs. It
Okay.
is catered towards deep analytics that you want to do with it. All right. Now, in turn, a big data cluster can go ahead and process a lot of that data, derive a filtered or aggregated insight from
I
it.
gotcha. And then you query that from the Node.js app.
Exactly. And feed it into, let's say, a Azure Cosmos DB or a
Or
Postgres or
MongoDB
a
or
MongoDB or a Cassandra or something like that. And that is where your Node.js applications are connecting to. Now, there are systems, and I will definitely mention that there are systems that actually connect end user applications sometimes to these big data systems. But those are very specific requirements for very specific needs, etc. And those are few and far in between.
Gotcha. So one other thing that I'm wondering about then, you mentioned, hey, we'll spread this across, 100 or 1,000 machines, right? And I start thinking about, okay, well, Amazon EC2 or Microsoft Azure, where I'm metered per hour of whatever instance I've got spun up. So, I mean, how expensive does this get depending on the size of your data structure? Is it less expensive than I'm thinking?
No, I mean, to be frank, big data is a workload that is expensive. So when you spin up 100 VMs, even if you spin it up for an hour for processing, that means you're leveraging 100 compute hours. So you're paying for 100 compute hours. But in essence, this is much cheaper when you compare it to what is the investment that you would need to make if you were to implement such a thing in, let's say, an on-prem bare metal environment. Right? Just imagine the upfront cost. First thing is like getting an approval, let alone 100 machines, getting an approval for even 4 machines to spin up a cluster, right? Now, the second piece over there is that all of these big data engines, when they're in the cloud, they're already leveraging the elasticity, the flexibility, and the scale out mechanisms of the cloud itself.
Right. I'm doing a job, create a bunch of these machines. Okay, I'm done with my job, fold them all back up, and I don't need to use them anymore. I'm not paying for them.
Exactly. And when you create these jobs, like as a developer, when you understand that, okay, this is the processing that I need to do, and these are the stages of my processing, you always append your first stage and your last stage to be that, okay, when I need the cluster, go spin this cluster up, go ahead and perform all of these stages, listen to the output of the last stage, and when that says green, go ahead and shut down the cluster. So it could potentially be that you planned the job for an hour, but your job got completed in 3 minutes. Your last stage over there is already listening to that green signal. When at the end of the 3 minutes, when you get that green signal, your cluster shut down. So it's not a time thing as such. It's more like a job stage process itself. Like you might not end up paying as much as you anticipate as a result of creating a job.
Right, because I'm paying for 3 minutes times 1,000 servers instead of an hour times 1,000 servers, because
which reduces your cost like 20
Right.
times in this example.
yeah,
Right.
that makes sense. So what does the other thing I'm thinking about is, what does this data lake look like? I mean, is it just kind of a black box that you just here are a bunch of values, and it's kind of unstructured? Or am I looking at more like there are still tables and I'm still giving it some structure so that it knows what it's looking at?
Well, that's a good question. Imagine a data lake to be an infinite sized external hard disk that you can dump anything into. Now, you can absolutely go dump anything the way you want to and make a data swamp of it instead of a data lake, or you can structure it so that in a way that
Bucket for this,
bucket for
for
this,
that.
bucket
Yeah.
for that, etc. Like a folder for your movies, and a folder for your audio files, and a folder for all the work stuff, and folder for all the business stuff. And that's how most of our users, our customers, use it as well. Like they would go ahead and bucket it for specific use cases. For example, finance could be a bucket, manufacturing could be a bucket, factory flows could be a bucket, social data could be a bucket, clickstream logs could be a bucket, external third-party data could be a bucket, IoT sensor events could be a bucket, podcast files could be a bucket over there. And then when you're trying to process it, you're literally going ahead and giving the query, instead of giving it a table name, you're just pointing it to that bucket and saying, okay, go to this bucket, look for anything that's come after this date, and go ahead and help me process this using the same logic I wrote
Anything
last
that has this metadata, anything that matches this text search. Yeah.
Absolutely. And that's the way you go ahead and leverage it. And that's the way you maintain the sanity of the lake. Otherwise, it's very easy for you to make a data swamp out of a data lake.
Right. Gotcha. Well, we only have this room until 5, and it's 5. But yeah, these are some of the questions that I've always just wanted to ask about big data. Now, just to wrap up, one of the things that we do on this show is we wrap up with picks. And they're essentially just shout outs about whatever, right? So if you found a recipe you really like, or a TV show you've been enjoying lately, or a coding tool, or anything else, it doesn't have to be technical. It can be whatever you want. But yeah, do you have 2 or 3 things that you're just thinking, man, this week, this thing has been really awesome?
For you, the listeners of JavaScript Jabber, Loot Crate is offering an opportunity to save 10% on any new subscription at lootcrate.com. Just enter the promo code BRIDGE10 for 10% savings. Loot Crate is one of my favorite things. Every month I get a box in the mail, costs less than $20, and it comes with all kinds of goodies. I have stuff from, just looking at my shelf, Batman, Spider-Man, Ninja Turtles, Back to the Future, Lord of the Rings, Star Wars, and much, much more. So if you're a geek, a gamer, anything like that, and you want cool stuff to put around your office, cool t-shirts, comic books, etc., then definitely check out Loot Crate. To save 10% on your new subscription, go to lootcrate.com/Ruby. Again, that's lootcrate.com/Ruby to save 10% on any new subscription. Enter the promo code BRIDGE10 for 10% savings.
I don't. There's just too many of those to narrow down to just 2 or 3 of those. Actually, while my flight, I'm a Seattleite. Well, on my flight to New York City for the Connect event, I met. Fortunately, they turned out to be one of our customers, and I was just talking to them about the big data stuff, and who hooked me on to a Netflix series called Robot or Robot Eye, which is essentially the implementation of these data technologies into a series where they are seeing the implementation of these and trying to determine what the outcome of it is going to look like, say 10 years or 15 years in the future. It was something that really struck with me. Yeah. But yeah, apart from that, yesterday's announcements, I think Azure Databricks, that really is a game changer. Yeah, I was amazed by that thing, and I can't get enough of it since then.
Yep.
Yeah.
Very cool. Well, I'm going to jump in here with a couple of picks. So when I came out here, one of the things that I brought with me was audio equipment. Now, we're not recording on my equipment. My equipment's sitting in a bag on the other side of the room because it's the last interview of the day. But, I essentially brought the same thing that everybody else brought. So the hardware we're recording on is actually a Zoom H6. It's kind of a studio in a box. And, you can probably see here, but it's got, controls for all the different pieces. It's also got a port on the end where you can plug in different kinds of microphones. And I've used it for other shows. And it's just really terrific. But it also comes with 4 XLR plugs, which have microphones plugged into them right now. But if you pulled those out, there are also 1/4-inch plugs. So you can just plug in the larger of what's kind of a traditional headphone jack. And then it has a monitoring jack on it, so you can look at that. And then it has an equalizer on the screen. So when I'm talking, I can see the green going up and down. And when Nishant talks, I can see, the green going up and down on his channel. And so anyway, it's just a really, really powerful thing. And then it just takes an SD card. So I ordered a 64 gig SD card off of Amazon. It showed up at my house about a week before the conference, and I was good to go. The other thing that I brought with me are Shure SM58 microphones. Now, if you're into audio recording, especially if you've kind of done, these are the ones that I remember seeing like at school when I was at school. They're like $50 microphones. The nice Shure SM microphones are like $100. And, so I had a couple of them in my bag and a couple of XLR cables. And the Zoom H6 provides phantom power. In other words, it powers the mics. The mics require power. And so, so a Shure SM58 or 2, which is what I have. And then the Zoom H6 are really terrific. I'm also going to pick the mics that they have in this room. I don't remember what brand they are, but they're microphones that kind of go over your ear, and then they kind of come out in front of your face a little bit. They're kind of the wire mics that you see at presentations and stuff. And these particular ones, the thing that's really nice about them is that they dampen the room noise a little bit because they're so close to your mouth that it just picks up the near range and filters out the far range. The Shures do that as well, just not as well as these. So anyway, I'm pretty happy with the setup that we've got going here. And I'm looking forward to doing more remote recordings for this. So anyway, those are my picks. I'm just looking at the mics here to see if there's a brand name on them somewhere, and I just don't see it. So anyway, thank you for coming and talking to us about big data. I think this was a really great introduction to the topic. And if you want to hear more about big data, just let me know. People generally have my email. It's chuck@devchat.tv. And if people want to get a hold of you or check out what's going on with Microsoft and data, where do they go?
Well, my blogs, MSDN blogs, tag is null interface. So
nice.
They can look me up over there. And my Twitter handles at Nishant Thacker. That's NISHANT THACKER all together. Feel free to tweet me. Feel free to follow me.
All right. Sounds good. Well, we'll go ahead and wrap this one up. This is the last interview for Microsoft Connect. But thanks for listening, and we will be back next week.
Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.